Let's look at this set. Each of the 10 persons, namely A, Q, R, Z, M, N, P, B, K, and L, are wearing a shirt. The color of each shirt is one out of blue, green, and red. There are 10 people, there are 3 colors. There are 10 chairs placed in a row. The chairs are consecutively numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. From left to right in that order. These 10 persons have to sit on the chairs such that there is only one person in each chair. The number of persons wearing a green and blue shirt is 2 and 3. So they've also told us there are 5 people who are wearing a red shirt. This is also informed to us. Okay. No 2 persons wearing blue shirts sit on consecutively numbered chairs. There are 3 people who are wearing blue. So blue, and blue. Maybe the blanks at the either end get filled, but blanks in between definitely have to be filled. The instruction has been written in diagrammatic form or symbology form. Next, among the persons wearing red shirts, exactly 3 persons always is sitting together while the remaining 2 never. Which is to say, I will have red, then some red, then some red, and of course they can flip positions amongst each other. This is the second instruction. Okay. A person wearing a blue shirt and the person wearing a green shirt never sit on consecutively numbered chairs. So I cannot have BG. I also cannot have GB. Blue, green, green, blue cannot happen. The person wearing a green shirt cannot sit on chairs numbered 2 or 9. A person wearing a green shirt cannot sit on chairs numbered 2 or 9. Okay. Persons wearing a red shirt are not sitting at an extreme end. Okay. Persons wearing a red shirt are not sitting at an extreme end. Red cannot be at an extreme end. Okay. So if red is not at an extreme end, let's see. I have 2 G's to fill up somewhere and 3 B's to fill up somewhere. See, if I put the 2 G's at this end, condition 4 is violated. Condition 4 is violated. 2 or 9 cannot have the G or the green color t-shirt. This is done. So G here I put. Now B cannot come here. G cannot come here. Nothing. I will worry about it later. Now there are 3 slots left for 3 B's. Now let's try and identify where can we put a G. Slot numbers. I don't know where can we include a G. If I include a G here, G would be at slot 2, which is unacceptable. These 3 R's had to be together. So I can't put G anywhere. If I put a G here, GB would be together. If I put a G after B, BG would be together. Not possible. I cannot put a G here. 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 Again, GB would be together. I cannot put a G here because I cannot put a G here because BG would be together. I cannot put a G here because GB would be together. I cannot put a G here because BG would be together. So can you see, putting G in the first spot is unacceptable because the second G, the second green t-shirt person will not have any spot available to him. Okay. Starting off with the base case all over again. The base case I'm working with is I have red, one red, and one red. And I am denoting these by these rectangular boxes. These rectangular boxes can switch places amongst themselves. G at this extreme is impossible. How about G at this extreme? If I put G here, B cannot come here. The B's would have to come here necessarily. The blue t-shirt people would have to come here necessarily. Again, see, if this is the right extreme, G is at the right extreme, I cannot have the second G here because it would be a violation. There is no G at spot 9. If this is spot 10, spot 9 cannot be a G. This is impossible. G cannot be here. G cannot be here because BG. G cannot be here because GB. G cannot be here because BG. G cannot be here because GB. Again, G cannot be here next to B. G cannot be here next to B. So if I put G at the left extreme or if I put G at the right extreme, in either case, I cannot possibly have any case created, which is to say G cannot come at extremes. We also had the information red cannot be at an extreme end. If red cannot be at an extreme end and G cannot be at an extreme end, can you see the only cases possible? If this is slot 1, the two extreme slots have to be filled up by blue only. Have to be filled up by blue only. If two extreme slots have to be filled up by blue only, now at one spot, one of these spots is going to have the other blue. Let's say one blue was here and two G's have to come. Where can they come? The only spot left is this, because these two R couldn't be together. And see, does this fulfill all conditions? Does this fulfill all conditions? No two persons wearing blue shirts sit on consecutively numbered chairs. Valid. Among the persons wearing red shirts, exactly 3 persons is always sitting together while the remaining 2 never. Valid. The person wearing a blue shirt and the person wearing a green shirt never sitting on consecutively numbered chairs. Absolutely. Blue and green are not together. Person wearing a blue colored shirt and the person wearing a green colored shirt is never sitting on consecutively numbered chairs. Yes, absolutely. And the person wearing a green colored shirt cannot sit in chairs number 2 or 9. Absolutely. All conditions are met here. But then this is not the only case possible. Another case that can be made, and right now, another case that can be made, understand, from this processing, we know the G's would be together. We know the reds, these boxes can flip over places, and B's, this G and this B can potentially flip places, which gives us lots of cases. So instead of randomly making storylines, what I will do is I will create 10 spaces and then try to fill up things. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I don't know how many cases will get created. I will make provisions for enough. If need be, I will make more cases at the bottom. But for the timing, this is what I know. Stuff that I know for certain. At the ends, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I know at the extreme ends, greens cannot come, reds cannot come. So they have to be blue and blue. Now I have 3 groupings of red, red, and red. They have to be rearranged. So I'm trying to put that down. Red, red, red. Then one red here. Then one red here. G here, G here, B here. I can have this arrangement. Now I'm flipping over this B and GG. So I'll have B, R, 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 G, G, R, B, R, B. This is going to be another case which is acceptable. Now this RRR, we could flip these 3 slots around, no? So I'll make B, R, B, B, R, B, R, 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 G, G, R, B. This is also an acceptable case. Now this R, this GG and BB, I can, this B and this GG I can flip over. So B, R, GG, R, 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 B, R, B. Now these 3 R's that are there, I can put them in the last spot also. So B, R, 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 and B, R, R, R. Here I'll have GG. Here I'll have B, then R, then B, then R, then B. Here I will have R, then GG, then R, then B. And this is the extent to which we can make cases. Remember, this RRR, this R, and this R. We had these spots available. These three can rearrange themselves in three ways. Look at the first two cases, RRR, RRR, the same case, RRR, RRR, same case, and RRR, RRR, same case. And within these, the extremes had to be filled up by B. Now, these two slots could be filled up either by GG or by a single B. And that flip over takes us to 3 into 2, 6 cases. All 6 cases have been identified here. Now, within these 6 cases, what is useful for us or what makes it wonderful for us is, can you see everything in slot 1? Everything in slot 1 is blue only. So can I say everything in slot 1 is blue, everything in slot 10 is blue, everything in slot 9 is red, everything in slot 2 is red. So I can also perhaps go ahead and identify these are all red. I'm marking them with the pink color. And these are all red. Similarly, the ones in the beginning are all blue. They have to be all blue. Now, we were told that 3 are blue. BAN, NBA, NAAA, NB. Can I say the blue ones are necessarily N, A, and B? In fact, in order to represent it, I'll do this N, A, and B. These fellows are blue. Also for the red ones, we have these mentioned. Let's see if we can identify them. I have P, I have Q, I have M, I have Z, I have R. Yes, 5 are done. Do I have K or L? No. So K and L, the two that are left, will necessarily be green. So I can put them down as K and L. These two are green. Now I know the color of each of these persons. So let me mark it in the diagram itself. K and L were always green. This is wonderful. K and L, L and K. These fellows are always green. The blue ones I will mark with the blue color. Let's see, NAB. So blue is here, BAN. The blue is here, the blue is here, the blue is here, the blue is here, and the blue is here. The blue folks are identified. Now, whichever box is not colored has to be red. This is 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 red. And this is red. Absolutely wonderful. We have all this identified. But remember, we had only read up until this 5th one. After this, there will be a shock to the system. The following table provides information about 6 different seating arrangements, namely 1, 2, 3, 4, 5, 6 of the 10 persons done by Mr. Creasy. He observed that out of all the seating arrangements done by him, there is one arrangement that is not consistent with the information under additional information. So one of these arrangements is unacceptable. Which arrangement is that? Hopefully you remember, we needed 3 reds together. In every arrangement, regardless of which one we end up making, we need 3 reds together. And can you see clearly in the first one itself, we don't have 3 reds together. We don't have. So this is the inconsistent arrangement. The rest of them are consistent. If I go ahead and name them 1 and 2 and 3 and 4 and 5 and 6, let's see. Blue, red, green, green. Blue, red, green, green, red, red, red. This is corresponding to the fourth arrangement that we have. Here we have blue, red, 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 green, green. This is corresponding to the second arrangement that we have. Blue, red, blue. So it has to be either the third one or the fifth one. Blue, red, red, red. So the third one, this is corresponding to the third arrangement that we have. Fifth one, blue, red, red, green, green. This is corresponding to the second arrangement that we have. And this is again corresponding to the second arrangement that we have. The rest of the arrangements have not even been used. It is just that people have been moved around. Okay. Let us get to individual questions. Which of the arrangements done by Mr. Crazy is not consistent with the information stated under additional information? We know arrangement 1 was inconsistent. So option 1. Which of the following persons is wearing a blue shirt? We know blue was NAB. So N is wearing a blue shirt. Which of the following persons is wearing a green shirt? K and L were wearing a green shirt. So K. Okay. Now, which of the following persons is not a permissible group of 4 persons such that the number of persons wearing a red, a green, and a blue is 2, 1, and 1? Red, blue, green had to be 2, 1, and 1. So see, L is green. This is green. This is blue. The remaining two are red and red. So this is permissible. This is blue. This is green. Q and Z were red and red. So this is permissible. A and N were both blue. We needed only one blue person. This is green. This is red. So this is the not permissible group. Answer should be C. For peace of mind, we'll also check the last one. This is blue. This is green. And these two are red. So this is permissible. Therefore, the correct answer here has to be option C. Again, I have the facility of coloring stuff and checking it on a screen. You don't have that facility when you're solving in the exam. In the exam, the best you can do is this. Another potential way in which you could have solved was, see, knowing this, the blues and the reds and the reds, the column 1 and column 2, this column 1, column 2, column 9, and column 10. These we were certain of. And the first question tells me which arrangement done by Mr. Crazy is not consistent with the information under additional information. Within these options, they did not give us arrangement 2 and they did not give us arrangement 4, which is to say these two are definitely consistent. If these two are definitely consistent, here itself, if these two are definitely consistent, this will enable you to reach answer for question number 2. For question number 2, we were asked which of the following is wearing a blue shirt. Can you see? N is present here, so it has to be a blue shirt. This way we can identify. Similarly, for question number 4, which of the following is not a permissible group? The third group has A and N. Both of them have to be wearing a blue shirt. So this is the non-permissible group. Question 2 and question 4 can perhaps only be done by understanding what question 1 is saying. Additionally, when you go on to fit it, let's say, if we were only interpreting question 2 and question 4, and even within that, we were only taking care of these. Getting rid of all the markings. Let's say, right now, you know, blue, N and A are in blue. N and A are definitely in blue. Also, because we are told which of the arrangements done by Mr. Crazy is not consistent, one of these arrangements, either 1 or 3 or 4 or 5 gets cancelled. Let's say if 1 gets cancelled, B has to be blue. Let's say if 3 gets cancelled, then B has to be blue. Let's say 5 gets cancelled, then B has to be blue. Let's say 6 gets cancelled, then B has to be blue. You can infer the fact that B is blue. B has to be blue from that itself. Additionally, Look at this. We know that three reds had to be together. Three reds had to be together. Now PMRZ, just this much. PMRZ in arrangement 1, PQ, two reds are together, and ZM, two reds are together. At this time itself, you can straight away say arrangement 1 is unacceptable. You don't really need to identify the color of everything right at the beginning. You can do it progressively while solving. And when you're solving it in the exam, I would expect this is how you will be solving instead of the way I did. That is done more for the purpose of explanation. But hopefully you realize, despite me having an advantage, it does not really stop us from getting to the right answer. Also, look at this. From the first case or from the second case, I know this is red. See, this is red. This is red. I know blue is B is blue from the other cases. Now, two together, greens were coming together. So the only way I can fit two greens are these two. And then the remaining Q has to be red. This way, from this you can identify, and then maybe you need to color, you don't need to color. But the working can be done differently here as well. It is just that because I have a distinct advantage of being able to write on screen, I am doing it in a more comprehensive and expansive manner. But in case you are doing it in an exam hall, we don't really have the facility to write on screen. So our working should be done accordingly. That will be all for this set.